density of water and how do you find the density of air. I will also teach you that how to calculate density. Before starting the lecture, click on the subscribe button and you will get access to our 100 of conceptual videos for free. Let me teach you the concept of mass and volume. Let's consider that there is a bike and a heavy truck. We all know that both the bike and the truck have well-known values of masses. The mass of the bike is smaller than the mass of the truck. Here, the bike occupies small space, while the truck occupies large space. So the bike occupies some space or volume and has some mass. Similarly, the truck also occupies some space or volume and has some mass. In physics, when an object occupying some space or volume and has some mass is known as a matter. So according to physics, these both objects are matter. Remember this very important point for learning density. When there is mass, there is volume. Let me repeat it. When there is mass, there is volume. Now let me ask you a question. Is there exist any relationship between mass and volume? To learn this question, let's consider a box containing iron and a bag containing cotton. Let the mass of iron in the box is 1 kg and the mass of cotton in the bag is also 1 kg. Do you see the difference in volumes? I mean the difference in volumes between 1 kg iron and 1 kg cotton. Even in our daily life or here in this example, we can see the difference in volumes. Although the mass of iron and cotton is 1 kg, but the volume of 1 kg cotton is greater than the volume of 1 kg iron. Or one can say that 1 kg iron occupies small space than 1 kg cotton. To solve this mass and volume puzzle, you must learn the arrangement of molecules or atoms both in iron and in cotton. The molecules of the iron are closely packed together in uniform pattern, while the molecules of cotton are loosely packed together in a very non-uniform way. One another explanation is that the interspaces or distance among the molecules of iron is very small, while the interspaces or distance among the molecules of cotton is large. So the molecules of iron are closely packed and the molecules of cotton are loosely packed together. Therefore, iron occupies small space and has small volume, while cotton occupies large space and has large volume. Thus, the relationship between mass and volume depends upon the arrangement of atoms in a substance. Now, what is density? The definition of density is mass per unit volume. Or you can define density, the total mass of any substance present in 1 meter cube. Let me teach you a very different and a very easy definition of density. Let's consider 2 flasks. Let the volume of this flask is 1 meter cubed and the volume of this flask is also 1 meter cubed. Now it is filled from water and it is filled from petrol. After filling these 2 flasks, they both are placed on digital balance. Remember that here I neglect the mass of a flask. The mass of water in 1 meter cubed flask is 1000 kg, while the mass of petrol in 1 meter cubed flask is 800 kg. Hence, the density of water is 1000 kg per meter cubed, while the density of petrol is 800 kg per meter cubed. Remember that whenever you hear that the density of water is 1000 kg per meter cubed, think that there is 1000 kg water present and 1 meter cubed volume. Or when you hear that the density of petrol is 800 kg per meter cubed, think that there is 800 kg petrol present in 1 meter cubed volume. Now, what is the formula of density? The formula of density is equal to mass per unit volume, or rho is equal to m upon v. Remember that density is denoted by Greek letter rho. The SI unit of mass is kg, while the SI unit of volume is meter cubed. Thus, the SI unit of density is rho is equal to kg per meter cubed. Remember that if you increase the volume of a given mass, density will be decreased because there is inverse relationship between density and volume. Now let me teach you that how do you find the density of air. Let's consider a balloon. I fill this balloon from air. Let the volume of balloon filled from air is 4 meter cubed. Now I place this balloon on the digital balance. Let the mass of balloon filled with air is 5.2 kg. We know that density rho is equal to mass upon volume. Here the volume of air in the balloon is 4 meter cubed, while the mass of the air in the balloon is 5.2 kg. Thus rho is equal to 5.2 kg upon 4 meter cube. As a result, I will get 1.3 kg per meter cube. Let me also teach you that how can you find the density of water. Let again consider a big flask of 2 meter cubed. First of all, measure the mass of empty flask on electronic balance. Let the mass of empty flask is 6 kg. Now fill this 2 meter cube flask from water and place it on the electronic balance. Let the reading on the electronic balance is 200 kg. Now here the electronic balance shows combined masses of water and the 6 kg flask, while we only need the mass of water in 2 meter cube flask. So here I will minus the mass of flask from this reading. I know that the mass of flask is 6 kg. Hence, mass of water is equal to 2000 kg minus 6 kg. I will get mass of water is equal to 1994 kg. Thus, the mass of water in the flask is 1994 kg, while the volume of flask is 2 meter cubed. We know that density rho is equal to mass upon volume. Now plug in these values in this equation. Thus rho is equal to 1994 kg upon 2 meter cube. As a result, we get rho is equal to 997 kg per meter cube.